Hey 60, how are ya? Hopefully you've had a nice day. Happy St. Patrick's Day. Today is March 17th, so you should have done your homework in your binder last night. And what did we have? What did we do? Do you remember? Oh, yeah. But anyway, today we're going to use addition properties to help simplify expressions. Let's go over some of your problems that you had from last night's homework so that you can make sure they're correct. I don't think anybody should have problems on number 1. So it was 1/8 plus 3/8, which is the denominators are the same. So I just add the numerators and I get 4/8, but I can't leave it 4/8 because it's not in simplest form. Okay, make sure to reduce this to simplest form. They each have a 4 in common, so that becomes 1/2. So number 1 should be 1/2. Number 2, it's a mixed, these are mixed numbers, but the good thing about the mixed numbers is we have common denominators, so that makes it easy. I'm only going to do like 2 of these and I'm going to jump to the harder ones. So we're going to add the whole parts together, 7, and then 8 15ths and 11 15ths gives me 19 15ths, but again, we can't leave 19 15ths there because you have a 1 whole in here, 15 over 15 is 1 whole. So I'm going to take the 15 over 15 out, add it to the 7, which gives me 8, and this leaves 4 15ths. Is everyone comfortable with that? I'm taking out the 15 over 15, and I'm giving it to the whole part, because there's more than enough in here. This is like an improper fraction, 1 and 4 15ths. So I'm adding that 1 to the whole part, and this should have been your final answer. If you didn't do that and you left this fraction part of the mixed number with more than it should be, you got to fix that. You can't leave the fraction part of a mixed number improper. You could leave a number improper, but not a mixed number. The fraction part must not be improper, meaning the numerator cannot be higher than the denominator. So make sure you go back to fix that. Number 3 should be fine. 4, 5, 6. Let's start with number 7. We'll do a couple of these really quick. 7/8 plus 5/12. I can't add these in this form because they don't have common denominators. So I'm going to find the common denominator. A lot of you are just going to multiply 8 times 12. That seems kind of big though. Let's use a smaller one, like 24. That's the whole idea we went through how to find the LCDs, was so that when you're rewriting your fraction, you're using a number that's manageable. I don't want to use a really big number because when we use really big numbers, then mistakes happen. And so we try to want to make sure that we don't make mistakes. So using the things that we've learned, the least common denominator, and how to find that is going to help this be a less painful process for you guys. So 8 went to 24 by multiplying it by 3. 7 times 3, I'm rewriting this fraction, and they're equivalent to each other. Here I'm going to multiply by 2. 12 times 2 gave me 24, so that's 10. I keep my denominator and I add the numerators, 31 24ths. Now, this is fine to leave because it's just an improper fraction. The numerator is greater. You can change it to a mixed number if you like, but I really like improper fractions. But do remember, when you have a mixed number, you can't leave the fractional part improper. You have to fix that. Okay. Let's jump down to number 10, which was 9 minus 6 3/5. I think we went over this one yesterday. Can't remember. But if so, I would make that 9 over 1 because it's a fraction, right? That's a rational number. Any number can be expressed as a fraction. This I'm going to change to an improper fraction, which gives me 33/5. They don't have common denominators in order to subtract them, so I have to get that. So this changes to 45/5 minus 33/5. Now they have common denominators. I subtract the numerators, which gives me 12/5, right? Careful, I don't have anyone to correct me. Jan's not in here, just the ghost of Jan. He's in here. So we have 12/5 for number 10. Let's jump to number, what did I tell you? Did we go through, I think we went through 15. Let's do number 12. 8 1/5 minus 4 5/6. Again, not common denominators. I don't like mixed numbers, so I'm going to change these to improper fractions, because that's how I roll. 24 plus 5 is 29/6. Multiply this guy by 6 and this guy by 5. My common denominator is going to be 30. I feel like we did this one yesterday. 246, and that was 5 carry. Yep, we did this one yesterday. I remember these numbers for sure. Then we subtracted 246 minus 145. We did this on the video yesterday together. And we got 101 over 30. We talked about divisibility rules and how important it is when we get larger numbers and we have to reduce them because we can't leave fractions having common factors. But we are good with this one, 101 over 30. All right, hopefully your homework went okay for you. We're going to start on chapter 7 today. So if you want to open your textbook to page 222, we're going to use the addition properties to help us simplify expressions. We're going to use the addition properties. What are those? The funny thing about, hey, this class doesn't know you. Do you know any of these? My daughter Ruby's here. She's helping me. Oh, Phil, this has got, who's in here? Mary Kate Rye is in here, Cassie's in here, JT. Yeah, they were little when you were in 8th grade, so you might not remember Ruby. Okay, so we'll keep her quiet. We'll work on this. Okay, so these properties, don't get overwhelmed by them because they're not difficult. We're just hooking a name with something you already know. For example, do you know this? Do you know this? I don't need one.
Wow.
Right? Brenda, I know you know that, right? Everyone knows this. 4 plus 0 equals 4. It's saying any number plus 0 is equal to itself. There's a property that lets this happen. We're going to give it a name, just like you're a kids, right? And each of you have a name. So this property that says any number plus 0 is equal to itself is called the identity property. And it's of addition, the identity property of addition. We know that 4 plus 0 equals 4. When we add 0 to a number, it doesn't change the value. The identity stays the same. That's what helps me remember that the identity property has to deal with something staying the same. You don't lose your identity. So the number 4, when you add 0 to it, you stay 4. We hook a name to it, it's called the identity property of addition. True or false? 2 plus 3 is the same as 3 plus 2. Does everybody agree with that? 2 plus 3, well that's 5. Is that the same as 3 plus 2, which is 5? It's true, right? How is it that I was able to change the order and still get the same number? Did you notice that? 2 plus 3 is the same as 3 plus 2. I changed the order in which I added these two numbers, but my sum was the same. There's a property that says when you're adding two numbers and you change the order, you still get the same answer. Okay, so that means 4 plus 3 is the same as 3 plus 4. Is it true? 4 plus 3 is 7. 3 plus 4, 7. Yay, we get the same answer. There's a name to this. We're going to hook a name to this, which says the order, when I'm adding two numbers together, if I change the order, it doesn't affect the sum. It doesn't change the answer. This is called the commutative property. Hang on one second, guys. Sorry. Commutative. Please don't say community, because it's not. But people like to say it because they don't like to say it. But it's commutative, not community. This is the commutative property of addition. And it says any number plus another is equal to the order changed around. The order does not affect the end result. This helps us sometimes when we're doing a long math problem, like if I asked you to simplify this, 4 plus 26 plus 3 plus 97. If I asked you to simplify this problem right here, well, we've learned in math from Miss Metaxas and everyone before her that we go from the left to the right. We're looking for, please excuse my dear Aunt Sally. Oh, we've got all pluses, so I'm just going to go 97 plus 4. Now, doesn't that hurt your brain right there? 97 plus 4. It hurts my brain because it's not natural. I like to look, and most of us do, we look for numbers that give us tens. So instead of 97 plus 4, which isn't 10, any form of the number 10, it's 101. And then it's 101 plus 26, and then plus 3. Is there an easier way to add two of these numbers versus going from left to right? Can I change the order? For example, don't you think 97 plus 3 would be easier to add together? Because that's 100. And then 4 plus 26 is 30. That makes it so much easier. And I get my final answer way quicker because I looked around and I said, are there some numbers here that are easier to add together versus just going from left to right like I've been taught all these years? So you kind of pick and choose. And you can do that because the commutative property says you may change the order in which you add numbers if it makes your life easier. And it sure did make mine easier because I like to look for hundreds and tens and 30s. Those types of numbers which are easier to add together versus just moving left to right without saying, do I have a choice here? Can I move these numbers around? And you do. The commutative property of addition says you can change the order. You can change the order of how you add together numbers. We can change the order to make it easier for us. Nothing new. You probably know that you can do that. I can change these around and add the numbers that I want. I'm just hooking on the reason why we can do it. The commutative property of addition allows us to affect the order in which we add. Okay, so far we have 2, and of course these should go on your index cards or on your Quizlet so that you can study these because they are very important and will stay with you for a very long time. So far we have the identity property of addition, which says any number plus 0 is equal to itself. And we have the commutative, not community, commutative property of addition, which allows me to change the order in which I add together numbers. If you notice, these are properties of addition.